Dr. Sonage BK, Professor in Mechanical Engineering, will be delivering a short lecture on vapor or gas as a refrigerant. Gas as a refrigerant. We discussed already about reversed Carnot cycle. State 1 to 2 to 3 to 4 and to 1. This is a reversed Carnot cycle. This cycle is plotted on temperature versus entropy chart. If you look at the cycle, this cycle is operated within this dome of this curve. This curve is called as saturation curve. Within the dome of this saturation curve, the phase of the working fluid is liquid plus vapor. And on this side, the phase is a vapor. And on this side, the phase is a liquid. And this point is a critical point. Critical point means at this point, the latent heat of vaporization is 0. So this reversed Carnot cycle is operated within the dome. So that's why in this particular refrigeration cycle, vapor is used as a refrigerant. So if we start from state 2 to 3 is isentropic compression process. So in this process, the phase is liquid plus vapor. And then process 3 to 4 is condensation process, is carried out in the condenser. So here the state from 3 changes to 4, and at state 3 the phase is saturation vapor, and this saturation vapor is cooled to saturation liquid. So between this 3 to 4 the phase is liquid plus vapor. That means in this, the high temperature vapor refrigerant at saturated vapor condition will lose the heat to the atmosphere. TH is higher than the atmosphere. So the vapor, saturated vapor, it will get converted into saturated liquid. So state 4 is again on the saturation curve, but the state is liquid, and state 3 is on saturated vapor curve, so the state is dry vapor. 4 to 1, it is expansion process, and this process is an isentropic process, and it is carried out in the turbine. And here it is a liquid refrigerant, and after coming out of the turbine, that is expansion device, the phase is within the dome, so that's why at the state 1 the phase is liquid plus vapor, and this liquid plus vapor is again heated, heat is added from the cold medium through evaporator to the refrigerant. At state 1, refrigerant is liquid plus vapor. That means less is vapor, more is the liquid. And as the heat is added from the cold medium, then the balance liquid, it starts converting into vapor. That means at state 1, more is the liquid, less is the vapor. And at state 2, more is the vapor, less is the liquid. But at state 1 and 2, both are within the dome. So that's why the phase is liquid plus vapor. So at state 3 is a dry vapor only, and state 4 is a dry saturated liquid only, and state 1 is the liquid plus vapor, state 2 is also liquid plus vapor, and this is again compressed from state 2 to state 3. So this is called as a reversed Carnot cycle, in which vapor is used as a refrigerant. Now the same cycle, if I will draw beyond the critical point, the topmost point state of this saturation curve is called as the critical point. Beyond this critical point, in this superheated region, if I will operate this cycle, then this cycle, in this cycle, I am using as a gas as a refrigerant. In that cycle, no liquid you will observe in the cycle. So if this cycle is operated in this region, that is in superheated region, then that will become gas as a refrigerant in the reversed Carnot cycle. So as both are, that means gas as a refrigerant and vapor as a refrigerant, both are working on a reversed Carnot cycle in this particular example. That's why these both cycles, they are the ideal cycles, or you can call it as a reversible refrigerator. But practically, both these cycles, gas as a refrigerant and vapor as a refrigerant, they are not possible. Why they are not possible? Because you cannot stop the heating at a particular this state. That is very difficult to control this, because heating will continue till the saturation vapor. But to achieve this state and taking out the vapor at this state, supplying to the compressor, is very difficult task. And again, from 4 to 1, and at state again it is achieving liquid plus vapor state, is again difficult. And if this at state 2, liquid plus vapor refrigerant is present, and that liquid, it will entrap into the compressor, and it may damage to the compressor. So that's why this particular cycle is an ideal cycle. Practically, to run the refrigerator on this cycle is not possible. So this is about vapor as a refrigerant and gas as a refrigerant. So here in this picture, all the elements of the refrigeration system, they are shown. As I told, 2 to 3 is carried out in a compressor, 3 to 4 is carried out in a condenser, 4 to 1 is carried out in a turbine, or it is called as an expansion device, and 1 to 2 is again it is carried out in a evaporator. This cycle completes. That means in this heat is going out, in this particular element, it is going out to the atmosphere, and in this heat is going to added from the refrigeration space. And here to the compressor we are supplying the work in, and turbine work out. Work is developed. So like this, the vapor as a refrigerant and gas as a refrigerant, it works. Thank you.